Welcome to my channel RLD Academy. This is tutorial number 14 on signals and system. In this video, I'll discuss one problem from GATE 2016 ECE, and this problem is related to one system, LTI system, and one signal xt given, and you need to find out the average power of output signal. So this LTI system magnitude response is given. This is the magnitude response, and its phase response is also given here. And you see the signal xt is linear combination of sinusoidal signals. This is one cos signal, one sine signal, again one cos signal, and they are combined with some magnitudes. Now to solve this problem, you should have certain concept. So first I will discuss those concepts, then we will solve this problem. Let us see. Now, first you should have this knowledge that if you have a LTI system, so this is suppose LTI, and its impulse response HT, okay, and here if input signal xt is of this form, a cos 2 pi f naught t, one cos signal or a sine signal, whatever it is, then the output signal yt is again sinusoidal and frequency will remain same, only magnitude is modified and phase is also modified. Okay, so yt will be a times one magnitude m is multiplied, and that m is basically the magnitude at frequency f naught, that we'll discuss, and cos will remain cos, and 2 phi f naught t, with this one phase is added, phi. Okay, now where this m and phi, these two are magnitude and phase of this LTI system. So this LTI system, if its Fourier transform is h of f, right, then magnitude is m is actually h of f at f equal to f naught. Okay, that frequency, that will consider the h of f, and that magnitude is this m, and phase is the angle of h of f at f equal to f naught. Okay, that's a very simple idea. So what I'm saying, that in a LTI system, if its impulse response is given ht or its spectrum is given hf, in that case, if I apply a sinusoidal signal, a cos 2 pi f naught t, f naught is the frequency in hertz, then the output signal magnitude is modified. So here with a, m is multiplied, and m is the magnitude of the spectrum at f equal to f naught. Okay, and one phase is added, that phi is angle of h of f at f equal to f naught. Right? So as it is a LTI system, we can apply several such sinusoidal signals in linear combination. Again, we will get similar linear combination at the output end. So what I can say, that if this is the LTI system, okay, and its impulse response is h of t, then here if xt is such linear combination. Suppose A1 cos 2 pi f1t plus suppose A2 sin 2 pi f2t, then output yt will be very similar. It will be A1 into M1 cos 2 pi f1t plus phi 1 plus A2 M2 sine will remain sine 2 pi f2t plus phi 2, where you know that if this is h of f, then m1 is basically magnitude of h of f1 and m2 is magnitude of h of f2 and phi 1 is the angle h of f1 and phi 2 is the angle h of f2, right? Okay, now the power, how to calculate the power of a signal, periodic signal. Okay, now if a signal is xt, a cos or sine, whatever it is, something 2 pi f ct plus some phi, its power px, average power, is simply a square by 2. Okay, it does not depend on the frequency fc or the phase phi. It's only depending on the amplitude a, and average power is a square by 2. So we need to know the amplitude of the sinusoidal signals. So these are the important. So this phase is not important at all if we used to calculate the power. And if you have several such components, okay, sinusoidal things, then we can consider the Parseval's theorem, and there we can apply addition of all those things. Okay, so let us start with that one. Now, this is your system. The signal xt will be applied and output is yt, and the spectrum, so this is the frequency f, this is your mod of h of f, right? So this shape we can plot. So at omega equal to f equal to 0, it is 1. At 20, it is becoming 0. So it is this shape, and beyond that is becoming 0. Similarly, minus 20 as well. It's a linear, it's triangular shape. Okay, and this is at 0, f equal to 0. So at f equal to 0, it is 1, and both sides it is decreasing, right? Now the frequency I can consider. So this one, the frequency is 20 pi equals to 2 pi f1. That means f1 equal to 10 Hz. Similarly for this one, f2 equals to 20 Hz, and for this one, f3 equals to 40 Hz. So those frequencies we can locate here. So we can locate this one. So this is your 10 Hz, this is your 20 Hz, and this is your 40 Hz. So we can calculate the magnitude at 10 Hz. We can calculate the magnitude here, calculate the magnitude here. Okay, so you see in this 3 region, for this one we have got F1 equals to 10 Hz, this F2 equals to 20 Hz, and F3 equals to 40 Hz, right? Now, we'll calculate the H of magnitude, M1. So M1 equals to magnitude of H F1. And from this figure, it shows that its value is 1 minus 10 by 20. So it is half. So this 1 minus half is again half. So magnitude is half. And for this one, M equal to 20, it shows that it is 0. 1 minus 20 by 20 is 0. So magnitude is 0. And this F3 is beyond 20 Hz. So it is here. Okay, it is 0 again. So M3 is also 0. So M2 is 0 and M3 is also 0. So I don't bother about the phi because its phase could be phi 1, its phase could be phi 2, its phase could be phi 3. Power does not depend on the phase. Thus, we won't calculate phi. So what is the resulting signal yt? So therefore, yt would be, so 8 was the amplitude. Now M1 is multiplied, that is your half. And cos signal will remain cos 20 pi t and plus phi by 4 plus phi 1. It's okay. Next one, amplitude is becoming 0. So anything is multiplied by 0, that will become 0. Again, last one is also 0 because M3 is 0. Right? So this, it is becoming 4 cos 20 pi t plus phi by 4 plus phase phi 1. So what is the average power? So this power Py is simply the a square by 2. It's the 4 square by 2. Okay, so it is 16 by 2 and that is equal to 8 watt. Right? So it does not depend on the phi 1 and phi by 4, all those things, or frequency. Its amplitude is 4, thus the power is 4 square by 2, it's 8 watt. Right? I hope you have got the concept. So if you like this video, you can subscribe my channel, and to subscribe my channel, you can press the subscription button. Then don't forget to press bell button because then only you will get immediate notification of my future videos. And it is a free subscription, right? I hope you are going to subscribe my channel. Keep watching my videos. I'll be uploading lots of videos here. Thank you.